Hi, my name is Neil. I work for AppsFlyer. So they approached us a couple of months ago, or something like that, and they asked us to tell you a bit about what we're doing with BigQuery. So it's going to be a bit of the talk is storytelling. So it's going to be a bit of a storytelling. I've got the unique perspective of being in AppsFlyer from almost day one. I'm AppsFlyer's first employee. So I'm going to tell you a bit about what we do currently, but more interesting, I'm going to tell you how it all started and how we fumbled using BigQuery and how it cost us a lot of money, and how we try to optimize things, and what we're doing right now. Okay, so if any of you don't know AppsFlyer, AppsFlyer is a mobile attribution analytics platform. We're among the top 3 worldwide, some will say the first. We reside in Herzliya. We're currently around 150, 160 employees worldwide. We're based 10 locations in the world. Out of those, 45 people are in R&D. Okay? Technology stack that we use currently, which is not so relevant for the current talk, but we're a Clojure workshop. Okay, Clojure is the main development language, and we're running on Amazon. We're using loads of stuff: Docker, Couchbase, Aerospike, BigQuery, Redshift, Redis. If you name it, we've got it. Almost everything. Okay, we're big believers in open source projects and stuff like that. And currently, we're processing around 8 billion HTTP calls per day. Okay, that's a lot of data. And we'll see how it all started. Okay, so that's now, but in 2012 that wasn't the case, right? When I joined the company, it was like 2 people, the 2 co-founders are and Reshef, and I knew Reshef from before, so he asked me, I was just leaving a job, and he asked me if I wanted to join. I said, yeah, okay. So we set in an accelerator. We had like, it was a Python workshop at the beginning. Python is super easy to do startups, right? It's like super easy language, super easy to build some stuff that works really, really fast. And we're a Python workshop. We had like small services on Amazon. Little is known, but Redis has got a built-in pub/sub capabilities. Most people use it as a cache of a sort, but we use it as a pub/sub. Our main database was CouchDB. Any of you know CouchDB? Yeah? Okay, it's like an Erlang database, key value storage, document database. Okay? Not a whole lot going on, that's business-wise, right? At the time it was like a couple of thousand API calls a day, not a lot of business. But we started growing, and we left the accelerator, got our own office. We were like, yay, we're making business, okay. We got into the Russian market. We were like, people are actually paying to use us. Great, and we got a really big Russian customer, and really big at the time. Right now, he's one of our smallest clients. And one of the capabilities that we had was providing raw reports. So let's say that what is raw report? So we're receiving a lot of HTTP calls, and all of those HTTP calls are actually translated into either clicks on banners, or application launches, or some kind of activity inside the application, in-app event, purchase, whatever it may be. So one of the capabilities that the platform provided to clients was the ability to download the raw report, line-by-line report of everything that happens in a certain time frame. Okay? And we run it on CouchDB. And in order to run it on CouchDB, in order to index it, you've got to use a view. And when the view is created, when the view is created when you access the view, and when you access the view and the view is created, the database is kind of stuck, right? Because it's generating the view. So the main problem that we had is that the database that generated the view is also the database that stores all the raw data and does a lot of other stuff. And whenever a big client pulled the data, we were like, okay, everything freezes now, right? Everything freezes. And what's even more gruesome is that we're using Redis PubSub, and Redis PubSub is not like a message queue. Okay, there's no persistence there. If something doesn't pull the message, it's gone. So we're like, Reshef and myself, we're sitting in the office, we're looking at the graphs, and we're like, that's not good. But you know, it's a small business, and some events are disappearing. We're like, okay, they won't know this, so let's fix it fast, okay? And we thought about, okay, how to fix it really, really fast. We said, okay, we're an Amazon workshop, right? So let's do something on Amazon. Let's use Redshift, right? Anyone knows Redshift? Yeah. Okay. So Redshift is, it's like a BigQuery equivalent on Amazon. There are some major differences, but the most major difference for us was that Redshift is not a hosted solution. Okay. At the time, we were 2 people in the R&D, 3 people in the company. And we're like, okay, we need to provide a solution fast, okay? So we like looked around, and BigQuery came out, and we're like, we didn't do any research. It was not like, okay, let's spend some time and evaluate different solutions. No. We're like, okay, BigQuery, okay, it's hosted. It doesn't look like it costs a lot of money. Let's try it. Okay, that's how it went. So that's the quick solution. Okay, Google BigQuery. The time is circa the end of 2012, the beginning of 2013. Columnar storage database, really easy to start working with. We were a Python workshop. So the Python driver for BigQuery was really, really easy. I wrote up a service thinking like a day and a half, something like that. It started putting data into BigQuery, and like 2 days after that I wrote another service that was able to pull the data and press the solution, immediate solution for the immediate problem. And we're like, okay, it works. So we put it aside and we started writing more and more data into BigQuery. And like 6 months later, or I don't know if it's 6 months, but a couple of months later, we're starting, we're developing the product and stuff like that. And we started thinking about, are we really doing things okay inside BigQuery? So data in BigQuery is divided into projects, and inside projects are data sets, and inside data sets are tables. And we started thinking about this question, right? How to split the data, and is the performance constant, and how am I charged? And these are difficult questions, right? Because there's no easy answer. At the time, we took the really naive approach. Okay, one project, one data set, multiple tables, and we were starting to grow to the volume of hundreds of thousands of rows a month, which is not that much, okay? But it's still kind of big. And this is how the BigQuery UI looks like, the web UI. You've got some, these are the data sets, this is the project, and this is some table and some fields inside the table. Really easy to start working with. But what are the limitations? So one big limitation is that you cannot change the schema of the table once you created it, okay? And you cannot update the table data, and you cannot delete table data. So essentially it's only forward writing. So what happens if you make a boo-boo? What happens if you're writing stuff that isn't supposed to be there? Is there any way to fix it? The short answer is no. Okay, there isn't any way to fix it. So again, we scratched our heads and we were like, okay, you know, that's the naive approach. Let's see if we can live with it. So what did we do? We didn't have any persistent queue. We were working on the pub sub methodology. So what we did, we had a separate service that listened to the pub sub constantly. It dumped all the data into files, and the files were uploaded into BigQuery in the form of a jobs. And before we uploaded the files, we ran some sanity check on them to make sure that everything is okay. And again, the naive approach, right? At the beginning, we were like, okay, we're running some files, it's in the system, we're uploading them to BigQuery, and we're receiving an okay answer. It means the data is there, right? Wrong. Not always. Okay, so that's when stuff started being a bit hairy inside of BigQuery. So we encountered our first issues there. And again, I'm not saying that against BigQuery, because it's an excellent product, to the effect that when Demi approached me, I was like, what I'm going to say about BigQuery is like it's an SQL-like data store, and it works, and it's kind of boring. But boring is good for a hosted solution, right? Boring is good for a SaaS, right? Boring is constant. But we did have some issues with it, and one of the issues was that over time, some of the APIs of BigQuery changed without modifications, right? So some of the responses, like we used to accept a JSON response for an upload job, and the response, if there was some error, would have a field called error, and sometimes they change it from error to errors, plural. And we're checking for error, not errors. Okay, we lost data there, right? For sure. But that taught us a lot of stuff, right? That taught us, okay, when you upload the file, don't assume that if you get a response that it's okay. Put the file aside, monitor, like retrieve the job ID that's assigned to the upload job, and then request constantly, do a long polling from BigQuery, and only when you get a confirmation that everything is okay, only then delete the file. Okay.
Yeah.
Okay.
One more question. What's your single source of truth? Is it BigQuery, or you have it stored somewhere else?
Now or then?
Both.
So then it was usually BigQuery, but now it's not BigQuery. I'll get to it in a bit. Okay. And single source of truth is nice. It's really good when you're doing like hundreds of thousands of API calls. It's really good when you're doing millions of API calls. It's really difficult when you're doing billions of API calls. What's the single source of truth? If you're writing data in a raw format, line by line format into BigQuery, and you're writing data in aggregated format into another database, and there's a bit of a discrepancy, is it okay?
Until a certain place in time, I think. Let's say you have it updated until a day before, and when a day closes, you just aggregate the data.
Yeah. So
maybe, I don't know.
It's difficult. It's difficult. Look, there are no definite answers, right? So people can say like a 2% discrepancy or 1% discrepancy is good, but if it's really big numbers, the 1% can be also like a really big number. So no definite answers, but we'll get to what's the source of truth today. Okay. And another thing that happens with the modeling of BigQuery over time is that we talked about it before. The schema is constant. Okay, so so the product itself, AppsFlyer, as a company evolves and adds functionality and usability over time. And now the table X that I had before, I want to add some fields to it. I can't, right? The schema is defined. That's it. That's the schema. So how do you tackle that issue? So what did we do? The main purpose, or again, the only purpose of BigQuery and AppsFlyer is to drive the raw report. Nothing else. Okay? To that effect, we decided that one project is good enough for us. What we decided fairly early on is that we'll create a new data set every 30 days. Can anyone think of a reason? Yes?
You pay for all the data you query.
Sir?
You pay for all the data you query.
Sure. Okay, so BigQuery, again, you pay for the data that you query, so if I rotate the data set every 30 days, I query only the latest data set. But that's cost limitation. We also have some business limitation. One of the business limitations that we have in AppsFlyer is that we're partnered with many affiliates and clients and stuff like that. And some of them, such as Facebook and Twitter and Amazon, demand that we delete raw data after a certain amount of time. Yeah. Yeah.
Legally?
Legal. We need to delete the raw data after X amount of time. Contract bound.
That's because they send the data to you, or?
But Facebook stipulates that as a mobile measurement partner, I can't contain user level data on our end for more than 180 days. Okay? So I need to delete data, but I can't delete data in BigQuery. I can't delete certain rows in BigQuery. I can only delete entire tables. Okay? So in order to delete entire tables, I don't want to lose all of my data. I rotate the data set every 30 days, and then I can delete only all data, all the data sets or all tables from all data sets. And, sorry?
Can't you create a new table with go in the data that you need and read the old data?
You can, but it's a costly process. It's not that easy, especially if the table is big. And in order to conform to the rules, you have to do it every day. So it's a bit of a hard call. Tables in the data sets are version. And when I say version, it looks something like this. Okay? So what we see here are pairs of tables. One of them is B, one of them is C. One of them is B, and one of them is C. What's the difference?
Current and backup.
What?
Current and...
No. Another guess? Exactly. Schema changes. Okay, that's how we dealt with schema changes. So if we wanted to change something for a certain table, we said, okay, version B contains, at the time, I don't know, I'm not sure that even now it's possible, but at the time, you couldn't query metadata from BigQuery. You couldn't query the data from the table. What?
Yeah. You can now.
You can now? So it's later edition. At the time, it wasn't available. So what we said, okay, I know that table version B contains these fields, okay, and table version C contains these fields plus, I don't know, X, Y, and Z, okay? And at our backend, we had a mapping. We knew that mapping B is for this and mapping C is for that, and the queries were run against them accordingly, okay? And we did all the merging and all the stuff on our end.
How come you have only two versions? How come it's not version hell, like 5?
We don't have only two versions. Right now we're up to version K or something like that, but we try to keep it to a minimum, and things change. We'll talk about it a bit later. We tried not to make a new version for every hiccup in the system. We tried to consolidate a lot of changes and then push a version outside. Okay?
And you're running them simultaneously? All of the versions?
So when I switch to a new version, that means I'm stopping writing to B and started writing only to C.
It's only, yeah.
Yeah. So, but I'm reading from both if needed. Okay. What do we look like now? So things changed a lot from 2012. And right now, it's a nice slide, but the stuff that even right now are not that updated because we're changing a lot of stuff as we go along. But that's the main architecture of AppsFlyer. So the main pipeline in AppsFlyer, we of course discarded Redis because pops up and a single source of failure and blah 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 blah. And we're using Kafka. Kafka is the main pipeline of the system right now. Anyone familiar with Kafka? Right. Few words about Kafka. It's nice.
Simple.
Simple, nice. It works.
Reliable.
Reliable. Yeah. We had some issues with Kafka as well. Especially, we started using it back at version 0.7, which wasn't that production ready. But since version 0.8, it's really good. Now we're already at 0.9. So Kafka is the main driver for everything in AppsFlyer. And if you're talking about the source of truth, it's Kafka. Yeah, Kafka is a single source of truth. How do we do it? We can't store everything inside Kafka, right? Because 8 billion daily events will flood Kafka within, I don't know, 3 days, 2 days, something like that. Okay? The Kafka cluster is 24 machines, something like that in AppsFlyer, and they're not small machines, they're big machines. So what we're doing, we're using a project called Secor. I think it's from Pinterest.
Yeah.
What? Yeah, so what Secor does is reading from topics in Kafka, dumping into files and uploading to S3. Okay, and it's really nice because it's uploading to S3 in sequence files of Kafka. So it's the data as it was in Kafka, including the offsets, including everything. So that's the single source of truth.
And it updates it daily?
It updates it as
Or
much as you want to tell it,
yeah,
but right now we're doing hourly.
And
Hourly.
how big are the files in S3?
It depends on the topic and on the amount of data. But they're
you're
big.
trying as big as you can, probably,
They're
right? Because
big.
of sequence files.
Yeah, they're big. They're big, but it's okay.
No, I know.
It's okay.
It's better than
Yeah.
S3.
So this is gone. What we're doing is a bit more complex than it is. From Secor, it's to sequence files, and from sequence files, we're transferring it into Parquet files, and from Parquet files, we're running Spark jobs and stuff like that. No Hadoop, Spark, lots of Spark streaming. We also started using Druid, but that's, we're doing a lot of stuff on the analytics side, but that's besides the point. Let's talk a bit about this. Okay, about BigQuery. So oddly enough, the first service in AppsFlyer that was written in Clojure was the service that queried BigQuery. What happened is that Python is really, really nice, but we had a single service that queried BigQuery. And when you query a lot of data from BigQuery, what it does, it retains a lot of in-memory string, right? 200,000 rows of string data. It can explode the Python service because Python has a bit of a hard time releasing memory back into the OS if it's strings. So we're like, okay, there are a couple of venues we can go there. We can do like CPython or PyPy or C to query BigQuery via C with Python, or we can do like a different language. So at the time, it was, again, just Roshef and myself, and maybe alone here also, I don't remember. And we were like, okay, Python is nice, but we know we're growing, so we probably want another programming language in the arsenal. We wanted something functional. So we spent a lot of time, and at the end we chose Clojure, which is a Lisp dialect that runs over the JVM. It's really, really nice. recommended wholeheartedly. So BigQuery. Okay, so we wrote a service, and we're rotating the data sets, and we're versioning the tables, and everything's running, but we're having Richmond's problems, right? Because why? At the beginning, it was like tens of thousands of API calls, 100,000s, millions. At the beginning of 2015, at the beginning of 2014, we were like 250 million API calls a day. At the beginning of 2015, we were 2 billion API calls a day. Right now, it's 8 billion. Okay, so it keeps growing. And now we come to this, the cost problem. Is there a problem? So again, storage is very, very cheap, right? Storage is extremely cheap. You can almost ignore the storage cost. But querying is built by the amount of data scanned. And BigQuery is a columnar database, okay? Which means that every column that participates in the query is read from beginning to end. And if it's a big table, and you select multiple columns, it doesn't matter if it's in the select clause, in the where clause, as long as the columns are there, you're built. Okay? So it can cost a lot of money. And again, once table starts storing a lot of data, even simple queries with very few columns will be expensive. How expensive? How expensive? So, a short story. We have some big clients, and some of them are using in-app activity in an extreme manner, and for every piece in their application, they're sending API calls to our servers, and we're storing it in BigQuery. So back in, I don't know, like a year ago, the average BigQuery bill was around, I don't know, $20,000 a month, which is not cheap, right? But it's not super expensive for the amount of data that we have. And one of the months it's jumped to 100,000, and a month later it jumped close to 200,000. And we're like, okay, we can't do $200,000 a month, but it's expensive. What happened is that the table that stored the in-app events for 30 days, again, the data set is for 30 days, it was extremely big. Extremely. Okay? So even if a single client queries a single day, if I go over the entire 30 days, it will be extremely expensive. How do you handle it? What are the optimizations? So, okay, out of the 8 billion daily events, we don't store everything, right? We store only the meaningful data. We've got a lot of data that is not so meaningful, not so insightful, so we don't push it into BigQuery because we've got it on S3. If we want to process it, we've got it on S3 on the side, and it can be like a Spark job or something like that. We've created, and we're pushing right now into production, a unified schema that will prevent table versions, okay? That will help us go along. So what we're saying is, okay, we know where the product is going, okay? We don't want to deal with the versioning, so let's create like a unified version. Doesn't really matter for where we're going. Let's create a big unified version, and then we don't have to deal with all this versioning, because versioning and stuff like that can have big impact on the code side and operation side. This is extremely important. We discovered it not so long ago. Tables can be query optimized via table decorators. That means that even if I've got a table that contains 30 days of data, I can give the query a decorator that says query only the last 7 days. That reduces the cost significantly. Okay? And you don't have to change anything on the schema or the table level. You only have to add some flag to your query. That's it. And what we will do, what we're working on right now, is Google has some nice feature for a long time, but we haven't been able to push it into production yet, which is querying by wildcards. Okay, so you can have like table X, and you can call it X with a date part after it, and you can do X date part 1, X date part 2, X date part 3, and when you query, give me all X's from date part 1 to date part 10. Okay, and then you query only the time range that you want. Okay, only the tables that you want.
In the macro, in the table name,
You put it in the table name.
it's in the metadata.
It's in, no, not in the metadata. You put it as the table name, and when you query the table, you can say select from table, and then you provide like a range of dates, and that's it. With that, it knows how to do it automatically. Okay, BigQuery supports it. The cost of cost optimization, because every feature's got a hidden feature, right? So performance. Querying multiple tables is usually less performant than querying one table. That's just how it goes. Over-engineering, we talked about it. Inserting into daily tables, the code becomes a bit more complex. And we talked about this as well. We're also moving, again, from the load operation, the batch jobs, into the streaming API right now. We didn't move into it beforehand because when BigQuery released the streaming API, it didn't hold the capacity that we wanted. We had more events in the load jobs than the streaming API was capable of, so we delayed it, and a year ago I think it was also up to par, but we delayed it 2 years ago because we were working on a lot of other stuff. And what are we waiting for? Custom partitioning functions. This is coming, I think it's at the end of Q2, something like that. And that means that besides partitioning the table by dates or by something like that, I can partition by a custom function that I provide based on one column or more, and the table will be partitioned. And this is huge for us, okay? Because that means that I can not only partition by dates, which is fairly easy to do in code, but if I want to partition even more, let's say by applications or by clients, the code will become convoluted. But if I can do it on the platform level, it's super easy. So we're really waiting for that, because that will probably lower the costs even more.
But you still have that 30-day issue of the raw data.
We still have the 30-day issues, and we're still obligated to deliver. Yeah, that's something we still have. That's it. Questions? No? Yes? Yes? No? No. Thank you.
Thank you very much.